Hello everyone. Well, we are done with 3D figures, we are done with shapes, we are moving on to probability. So there's going to be three categories that we talk about in probability. The first is fundamental counting principle, the second is going to be permutations, and the third will be combinations. They're all kind of similar, yet a little bit different. And then that'll take us up to like May 17th. And then the last week we'll do actual probability, like finding odds and stuff like that. So fundamental counting principle. Now before we get to that, let's briefly talk about what probability is. So probability is the likelihood or the odds of an event occurring. Now in order for that to happen, there are two different things that are needed. Right, so probability is usually represented as a fraction or percent. So in order to find the probability, the first thing that you're going to have to find is the total number of possibilities. We also call that the sample space, so the total number of outcomes. That goes in the denominator. Then what goes in the numerator is your total number of desired outcomes. So if we're trying to find the probability of an event happening, it's the number of desired outcomes divided by the total number of possible outcomes. And so what we're going to focus on today is the fundamental counting principle. And what the fundamental counting principle does is it helps us find that total number of different outcomes. So we're looking for this information here. That's all we're doing today. The reason why that's important is because in order to find probability, you first need to figure out what the number of possibilities is total. Okay? So again, we call that total different number of outcomes the sample space. Now, we're going to look at a really simple problem. And the thing to understand is that probability is usually looked at in multiple stages. Now, yes, you can have, all right, what's the probability of rolling a 2 when you're rolling die, or one single die. But we're going to be looking at probability regarding multiple stages. So multiple things happening, what are the odds or what is the probability of one singular event or multiple events with multiple stages. So here's a good example. Let's think about when you're getting dressed. Okay, now with that blue that I just put out, this is the FCP, or the fundamental counting principle, is the product of the choices in each stage. And I'll kind of come back to that here in a second. So what I want you to do is kind of just watch this part of this video. Don't write anything down that I'm about to show you, because this is the long way. I'm going to show you a much shorter way. So now I want you to think about in the morning when you're getting dressed, right? Let's simplify the outfit. Let's think you have shirts, pants, socks, and shoes. And let's simplify it even more. Let's say you only have 3 shirts, 2 pants, 3 socks, and 2 pairs of shoes to pick from. The question is, what is the total number of outfits that you can put together that are different? So what is the total number of different outfits? Okay, so again, this would be our sample space. Now, what you have to think about is each shirt that you wear can have different pants, different socks, and different shoes. So before we start getting into the FCP, I'm going to create what's called a tree diagram. So again, you're not writing this down, you're just kind of looking. So notice each one of those represents the first 2 stages of getting dressed. So you first pick a shirt, that's what the purple is for. Then once you pick a shirt, you have 2 pants to pick from. So again, this is shirt 1, shirt 2, and shirt 3 of our 3 different options. Well, once I pick a shirt, as I said, then we have to pick a pair of pants. I need to erase this because we're going to be going into it. And then once you pick a pair of pants, you have to pick socks. And then once you pick socks, then you have to pick shoes. So as you can see, this tree diagram is going to grow as we go through each stage. So this is our first 2 stages. We pick a shirt, then we pick a pant. Then once we pick pants, then we have to pick socks. And I have 3 different sock options from here. Once I pick socks, then I can pick shoes. So as you can see, right, this tree diagram just keeps growing and growing and growing the more decisions I have to make. And so let's follow one of these branches and kind of just so you can help understand how this works. Notice that was a lot of different options, right? So let's say let's just follow the top row. I pick this shirt, this pair of pants, this sock, and this shoe. So everything I highlighted in yellow, that's one outfit, right? Now I can pick the same shirt, the same pants, the same socks, but if I pick a different pair of shoes, that is a different outfit. So even though 3 of the 4 elements are the same, the fact that that 4th element is different, that means it's a completely different outfit. All right. So what's the total number of different outfits? We count the number of blue S's. So you would go all the way down and we'd count all of these guys all over here. And that gives us our total number of possible outfits, which in this case is 36. All right, so the thing is that takes way too long. So building a tree diagram takes way too long. The FCP, or the fundamental counting principle, that is going to shorten this up by more than half. And you'll see just how easy it is in the next video.